mejor en inglés. ¿Alguna preferencia? ¿Cuánta gente quiere castellano? Sube las manos. Bueno, pues... que quieran. Bueno, voy a probar a hacerlo en castellano y cuando me falta el vocabulario voy a cambiar un poco a inglés. Así que será un Spanglish, ¿no? Bueno, yo trabajo para MongoDB. La empresa detrás de MongoDB se llama Tengen. Está basado en Nueva York y yo he trabajado para ellos desde enero, pero he estado usando MongoDB más de 2 años porque soy el programador del driver de Node.js. Y también trabajo con Erlang y trabajo un poco con Java. Bueno, hoy vamos a dar más así un poco de una introducción a MongoDB. Así que algo va a ser técnico, algo no va a ser tan técnico. Tenemos un grupo de usuarios ya en Barcelona también, que la próxima semana tenemos una reunión. Al final de la presentación tengo un slide con la información de cuándo, dónde y cómo puedes fichar una plaza en el grupo de usuarios para ir. Y eso ya es mucho más de implementación y tecnología pura. Bueno, vamos a hablar un poco de dónde viene MongoDB y en qué espacio está en comparación con otros sistemas de bases operativos, sistemas de bases que tenemos por ahí. Un poco sobre cómo usarlo y un poco cómo ponerlo en producción y qué tipo de opciones de escalabilidad tiene el sistema de MongoDB. El clásico esquema de NoSQL se divide en 2 cosas. Toda la función de depth of functionality, ¿entiendes? En el sentido de cuántas posibilidades de manejar y modificar los datos tienes. Lo clásico que tienes todo a la derecha es el típico MySQL, Oracle, todas las bases relacionales donde puedes hacer joins, cambiar las tablas, tienes mucha posibilidad de cambiar y mucha funcionalidad en la base de datos. En el sentido contrario tienes Memcache, el típico sistema de llaves, donde tienes una llave, guardas un dato con una llave específica y solo lo puedes buscar por esa llave y tienes que saber la llave para coger la información. MongoDB se pone más o menos un poco entre las dos. Tenemos mucho más funcionalidad que los típicos sistemas de llaves como Memcache, pero tampoco tenemos toda la funcionalidad de una base relacional y eso es por diseño. Hay algunas decisiones que han cogido los fundadores de la empresa basado en su antepasado y su experiencia de construir sistemas grandes, complejos. Ya explicaré un poco de dónde vienen y por qué hicieron lo que hicieron con MongoDB. Lo primero es a lo mejor un poco conveniente dar un poco de información sobre qué es el espacio del NoSQL. Básicamente se divide en 4 partes. Tienes el key value, que son las típicas, el Redis, que son sistemas donde tienes que tener una llave, guardas los datos con esa llave y ya tienes que saber la llave para sacarlo. Son muy escalables, pero muy simples y no necesariamente un sistema que usas para modelar tus datos. Pero tienen su sitio en caches, en datos así temporales, tipo de esas cosas siempre se usa. Memcache es el más famoso porque lo usa cada aplicación del mundo para hacer caching de las páginas de web. De columnas viene básicamente de la idea de que tenía Google en lo que llaman Big Table, que era una manera de organizar datos para poder escalarlo a la masiva. Se parte más o menos en 2 partes. Tienes los sistemas de HPS, que es un Big Table, que está basado en un sistema escalable un poco diferente a, por ejemplo, Cassandra o RIA, que son basados en lo que son llaves distribuidas. La buena cosa es con un sistema como Cassandra RIA puedes meter X número de nodos de escritura y puedes escribir a todos los nodos. Cada nodo es básicamente su propio maestro, ¿no? Entonces, si quieres añadir más espacio, metes otro nodo. La complejidad es que es mucho más difícil hacer cosas como dame todos los documentos que tienen A menos de 10. A lo mejor en inglés es mejor, no sé. I'll do it in English. It's easier. I don't have enough practice in Spanish. Alright, so Cassandra is like Cassandra is a typical example of a hash string database. So every time you write a value, you pick generates a hash and puts it on a server. And depending on that hash string, you basically can load balance writes across multiple instances. Right? So every single server is actually a master, and all your data is spread up, sharded basically across multiple instances. Problem is obviously eventual consistency, which means that when you write, you have to wait for it to copy to a couple of different nodes, and eventually it will be all the nodes that you need for your application. It's a little bit more complex, but it scales really well if you know what you're doing. Harder to write an application around, so it's not something I would like pick as the first database to like start when I write my application. But it has some very, very, very useful cases. Graph databases is a completely separate beast. These are for like the typical relations between people or like entities. So if you want to model a social graph and you want to say something like if person A and person B have friends, which friends do they have in common? That's the kind of questions that you can ask really efficiently out of a graph database. The most famous one is probably Neo4j. And then on the document database side, that's where MongoDB belongs. It's basically the ability to store unstructured data. Right? And we'll get into some really simple examples on what we mean by unstructured data. The traditional thing that all developers deal with is called JSON objects. And so MongoDB is actually based on JSON with a little bit of a modification because we have types as well. But in general, you can say you can just store a document in JSON directly from somewhere else. And that's probably one of the reasons why it's become fairly popular. I'm just going to skip slightly over this. So key value stores, if you're going to do a resume summary, it's a mapping from a key to a value. And you don't really, the stores are very dumb, so they really don't know what they're storing. That's not completely true. For Redis, they do actually know somehow and somewhat what they're storing, but in general, this is the case. Column-oriented databases is literally like a relational database, but if you turn it this way. So you think about your data being lined up with first name, last name, whatever, you switch it around, and that's basically what you're looking at when you see a column database. Graph databases is basically a network between things. So it's a typical thing that a best example of this actually, every time you go on Google Maps and you put in a search to say, I want to go from here down to the ports in Barcelona, you're actually using a graph database, a very specialized graph database called Pregel. And Pregel is basically uses the fact that you know exactly how many nodes there are inside of a square, right? Because it's not like people pick up the roads and move them around all the time, right? So you can actually optimize for that, right? So you can basically say, okay, at there, I'm going to cut a square, right? And so Pregel is basically a bunch of little squares with graphs on them that are distributed on massively amounts of servers. And so when you ask, I want to go from here to there, it basically finds the squares that you have to walk through and then maps it through those squares. Some problems you will find if you run into graph databases and use them is that it's very, very hard to cut a graph and scale it. But they're trying. So the Neo4j guys are probably the ones that are the furthest. So if you're working on a social application, it might be worth having a look at Neo4j. So document stores. Well, documents are basically a collection of names and values, but they are nested. The closest analogy to what you're used to is that when you take notes in class or you take notes at a meeting, you always organize your data. You write notes with headlines and subtitles, and right? That's basically a document. And so document databases in many ways is just a computer version of your little piece of paper with your notes and indentations. They allow you basically to query on the documents. So you can say, give me all the documents that have a sub-document that contain a certain value. And you can insert and delete, and you can update. And in case of MongoDB and also CouchDB, which is another document database, you can modify individual fields inside of a document. You don't have to modify the whole documents. So that's MongoDB. So it's a very scalable, we think anyway, high performance, open source, NoSQL database. It's on GitHub, so you can actually go download the code and like mess around with it if you want. We're document oriented. We have full index support, including geospatial indexes, so you can do geoqueries. We have replication, and we have sharding. We allow ad hoc queries, which is close to how you work with SQL, with some limitations in compared to SQL, but that's just because we're only 3 years old as a database. We have really fast in-place updates, which means that you can actually modify data without copying it around, which is really beneficial. For querying data, we have, in the ways you can do it with the query language, we have something called MapReduce, which lets you basically go through the collection and generate new data. And we have a simple protocol written on top of MongoDB, which is called GridFS, which lets you store files, like binary files in the database. So the company behind MongoDB is Tengen. We're based in New York. I'm here. I'm Tengen Spain, basically. I'm actually an employee of Tengen Spain, so I'm the only one. The whole source is licensed under AGPL. So you can modify it. You just ask that if you do modify it, you actually contribute the code back. There's, for people who want to pay for support, that's what we live off. We live off that, consulting, and also special commercial licenses, because very big companies want to have specific license agreements. That's more the US, I think, where they're very used to like having specific commercial licenses in their software. Our management comes from like a little bit all over the place, but the two main founders came from DoubleClick. And DoubleClick was sold to Google. It was like one of the first ad networks out there. And the reason MongoDB came into creation was actually because our founder, Dwight, who's our CEO, and also still programs, he worked with, was one of the founders in DoubleClick, right? And when they were trying to scale this ad network in the early 2000s and around the dot-com boom, they were using Oracle databases. And they had massive problems because of the joins. Right? So they started like really denormalizing their databases because they couldn't handle the massive load. And they ended up building huge caches. And basically ended up like writing a NoSQL database on top of Oracle. Right? So when they sold DoubleClick to Google for, I don't know, $2.5 billion or something like that, after a while Dwight got bored of being rich, I guess, and said like, I want to do a startup again. And so he said like, the one problem that we could try to solve is this issue with scaling like the data store. And they basically started writing MongoDB. Well, really, they first started writing a full framework, then realized that the rest of the framework, nobody cared about it. It was the database that the people cared about. This is 3 years ago, pretty much about when the first release came out. We got funding from Sequoia, Union Square, and Flybridge, and people who follow entrepreneurial stuff, they will know at least the name Sequoia and Union Square. Sequoia is like the Google and Apple investors, basically. We got offices in New York, Palo Alto, London, Dublin, and Barcelona. And we're about 110 or 15 people now, so spread all over the world. So, MongoDB is actually written in C++, which is a good and a bad thing, right? It means that it's hard to program, but its performance is really good. We have drivers in pretty much every language. We have a couple of ones that are actually supported by us, which means there are actually people at Tangent working with them. C, C#, .NET, C++, Erlang, Haskell, Java, JavaScript, Perl, PHP, Python, Ruby, Scala, and me, Node.js. Then there's like a couple of really good community ones. So a good Clojure one. There's a very good Google Go one as well by a Brazilian guy. So there's like whatever language you're using, you're going to be able to like talk to MongoDB. So the history is very simple. August 2009 was version 1.0, and then basically we've been escalating like versions fairly rapidly. The version number always works like that. If it's a whole number, like 1.0 or 1.4, 1.6 is a stable version, and the unstable version would be 1.1, 1.3, 1.5. So as you see, what we've done here is basically slowly grown the amount of like features in the databases. So they're being grown based on what people have been asking and needing, right? The next version, 2.2, should be out sometime end of June, early July. You can download the 2.1 version and play around with it if you want to. It's got a new aggregation framework, which lets you do more stuff about like ordering your data. So like you can do groups and orders by what you're used to from MySQL. And we worked a lot on concurrency, which is like one of the things that people are very, very they have a need for that. So for the terminology is very similar. A table is a collection. A row is a document. An index is still an index in a database. A join is either done by embedding or linking, but there's no real joins in the database by design. Partitioning is a shard. And a partition key is a shard key. We'll just briefly touch on these, but not really go really deep in them. Documents. This is what a document looks like. There's no schema in MongoDB. So you basically don't start by saying, I'm going to have a document that has an author and that has to be a string of length of 100. You don't do that in MongoDB at all. You basically just put the fields in there. Making sure that you have the right fields is actually your job when you write the application. It can be kind of like unusual at the start, but then you really realize the flexibility of it. It also is kind of cool because since it's JSON based, basically, you can like say you grab some data of, I don't know, Twitter or something like that, using their APIs. It's all JSON. You can just turn around and just put that JSON straight into the database without having to do anything. So the typical thing that we see is like a lot of people using it to aggregate up data, for example, from other sources. And because it's like this rich nested structure, it's much more similar to how you are actually programming. Like you're used to writing object-oriented programming using Java or, JavaScript or PHP or anything. This is like much closer to the concept of how you actually organize your code. Querying is fairly simple. If you want to do all these things, get all of the posts, do DB, which is the current database you're in, post, find. I mean, this is actually happening in the console, right? There's a console in Mongo. It's actually a JavaScript interpreter, so you can actually program it if you want to. But this is basically happening in there. So we do a find, and we get back a document. And you'll notice that there's like this thing called underscore. That's just a unique identifier. It means that that number that's in here uniquely identifies this document inside of this table. So a little bit of extension as we saw here. This is called JSON, right? So we saw there's a couple of weird things there, isodate, object ID. These are part of like called BSON. And BSON just stands for binary JSON, and it's the way the database talks to the drivers and how it stores data. It just lets you say some stuff like, this field is date, right? And store a date, and letting the database sort your data by date, for example. Or if you have a number in there, make sure that it is a floating point number, or if it's a binary object, you can store a binary object in it. But for all and purposes, most people who are using writing their own APIs tend to use fairly close to just basic JSON, and then you're just using the normal JSON type. So then it looks exactly the same. We have like what's called secondary indexes. I'm sure you're all used to secondary indexes from SQL. We've used the indexes of course, right? Nobody's used indexes? All right. So indexes is like a way of querying your data very efficiently, and it's like the same rules apply for MongoDB as for MySQL or Postgres or Oracle. You need indexes if you want real good performance. And you can index on any field inside of a document, right? So in this case, we're adding an index on author and in descending form, right? So that means that when you do find one and you ask for the author Chris, it will use the index and not search through all of the data. We also allow you to create like what we call compound indexes, which means indexes that are over multiple fields. This is going technical, but basically you can say, I want an index that is by author in descending and then by timestamp on ascending. And that lets you basically more efficiently query the data. So this is quite technical, so we'll just go briefly through it. For query operators, we have a lot of things that look similar to what you're used to when you're using a SQL database. We have like less than equal, greater than equal. We have some operations that are a little bit different than your typical SQL database because they're meant to operate on embedded documents, for example. So, say you want to use, you want to find all of the posts that has tags, right? So you can basically say this, tags, and then exists true. That basically will like look in all your documents and see, oh, this document has tags, then return it. Otherwise, don't return it. You can use regular expressions as well. You have to be a little bit careful about that because if you do this, actually, it will scan all of the documents. You can also basically do a simple count if you want to. Like so, it's very similar to what you're used to when you're using a normal relational database. You also have like query plans. You can get an explanation of what you're actually doing when you issue this query. From the console, you just do db.post.find. In this case, we're asking for the author Ross, and we're doing explain. And explain will return and tell you exactly what's happened inside of the database in the moment you did that query. So in this case, we're really, really good because we only scanned one document, like one document here, and returned one document. So that's pretty much like that when it comes back from the database. You also have like atomic updates, right? So atomic updates is the way we modify documents in MongoDB. So let's say that we're modeling, in this case, a blog, right? And we want to add a comment to an existing blog post, right? So we have the person entered a new comment, Fred, best post ever. He wrote that in a little form on the website. You click save, right? And if you wanted to do a relational database, you probably would have like a separate table called comments, and you would type it there, right? But in this case, we're just going to say, well, we already have the blog document stored in the database. Let's just add that comment to that document under a new field called comments, right? So what we do is an atomic commit, right? We're going to do an atomic update. That means that like when this operation happens, nothing else will be changing in the document. So there's a guarantee that the document will be only written to by one thing at one time. So what we're doing is like we're fetching the document we want by the ID, and then we're doing a push on the field comments, and we're putting the new comments variable, like this document, into that field. And a push basically, if there is no field already existing called comments, will add an array and push that document into that array. At the same time, we're also incrementing the amounts of comments for that document. So inc will basically take the comments count variable in the document and increment it by 1. And if it doesn't exist, it will just set it to 1. And then the result will look like that. We now have nested documents. So this was what happened in the last operation. And as you can see, we now this is kind of like the richness of what you can do in a document database, right? Because you're kind of already realizing, I guess, if you have programmed for a while, that this would be your blog object, and this would be a method called comments that would have a list of comments object, right? So it's fairly similar already to the concept of how you're going to organize your code. The only difference is that this here is not in a separate database table. So when you pull back the data, you just pull back the whole document at one point in time. Of course, you have to keep in mind that if your blog is incredibly popular, this could be a massive amount of comments, and then you might have to actually normalize. You might actually have to split it into a separate comments collection. So it depends on your usage. There's always a trade-off in all systems.
Which is the limit, sorry, more or less?
16 megabytes per document. But you probably don't want to pull back 16 megabytes for exactly for if you have 20,000 comments or something like that, right? You don't want to pull that back every time you pull back the blog, right? You can exclude it, of course. I mean, when you in MongoDB, when you do a query, you can say, give me only these fields, for example, right? And forget about the other ones. But it wouldn't make it very easy for you to search those comments, right? So in that case, if you have 20,000, you would probably move this comment into a separate collection, just like you would in a relational database. This is one of the things I'm working a lot on now, is schema design and schema examples, so people can get used to how to model data for document databases. And the good thing is all the rules that apply to MongoDB apply to every single document database out there. So if you learn for this one, you'll be able to apply to any other data stores in the future. So we can have nested indexes, right? Notice the dot thing, the little dot operator. Well, that basically allows you to step into the document. So this basically says create an index on every single comment in the comments array for the author, right? So that will basically go through all the comments that you have in that array of comments and add the author to the index. That basically lets you do something like .db.post will find comments of author about Fred, and then we'll use the index. And it will actually look inside of the documents. There's some really cool things you can do with that, right? For example, saying that you have in the post, in this case we have tags, right? And you want to basically be able to pull back all the blog posts that have a certain tag, right? If you want to model this traditionally, you would probably end up in another table, again, with the relation between tags and the actual document itself, right? You would have document number 1 has this tag and this tag, and then one row for each, right? But because you can index inside of the document in this case, you can basically just say, I'll give you an index on tags, and then I'll say, give me all of the blog posts where they have a tag that match tag. So those kind of things are really, really, really nice and different from what you could do in traditional databases. Geospatial is another really cool thing, especially if you're into mobile and that kind of stuff. We developed this together with Foursquare. So Foursquare runs MongoDB for all the operations. Every time you check in somewhere, you're running a query through MongoDB. We can basically do stuff like finding points near to a given point. You can also do different polygons and spheres and stuff like that. So if you need to split up Barcelona into the little areas of Barcelona, you can say Gracia, and you can get the GIS data and create a shape, right? And you can say, give me all the points that are inside of Gracia or something. It's very, very simple. You can do an ensure index at the you say which field you want it to be, and you say 2D. The only thing is like you basically have to, and you can look at that on the web on our documentation. You basically just have to keep your two variables organized like correctly on the document, and then it will basically index them as a geo points. And then you can do something simple as find all the documents where the author location is near a specific coordinate, right? And you can also set like how far away from that point, right? So if you're writing a little mobile application that has geospatial awareness, it's really, really easy and really useful to look at something like MongoDB. It will save you some time. We also have like a MapReduce function, and MapReduce is basically allows you to create those queries that are a little bit more complicated. Reason for this is that there are certain things that you can't really do in MongoDB in the querying language as of for now, which are coming. Like if you want to do a group or order by, for example, operation on documents, you want to take all the documents and say, group them by every 5 minutes of given a time period. You can't do that with the querying language right now, so you have to use what is called MapReduce, and the MapReduce basically is two JavaScript functions that you run on the server. The map function takes data out and then like formats it and emits it, like sends it out. And the reduce basically takes the data that's been emitted and then like aggregates it together and then saves it somewhere. This you should never write your application front end part of your application to use this. It's too slow. So it's more for like changing data or reporting this kind of stuff. But it will get faster as well. Not this version of the database that's coming, but the next version will have the Google V8 engine. So it will have multi-threading, because now it runs in a single JavaScript thread, which is bad. But it will have multi-threading in the future, and it will have the performance of like Google V8, which is like Node.js, pretty much in focus. But yeah, you can actually run JavaScript inside of MongoDB. So an example is how you do it. Every driver pretty much has a helper for this function, MapReduce. Pass in a map, a reduce, you can set an out, which specifies like where you want to put the data. You can use this, for example, if you are, let's say you're aggregating up some data every 1 hour. Like you're taking a bunch of data coming in, you're changing some of it and saving it somewhere. You can basically use this to like save the data that comes from your MapReduce into another collection, or add to another collection. So it's a very useful thing. It's just something you shouldn't use on the front side of your application. What's coming in 2.2, which is really cool and which is going to solve a lot of the problems with MapReduce, is aggregation, the aggregation framework. The aggregation framework is basically order by and group by and a couple of other richer ways of aggregating your data. So if you use Linux, you're used to doing something like, more some file, pipe it to grep, and then do something else, right? So you're passing the data and transforming it across multiple steps. The aggregation framework works exactly the same way. It's basically a set of operations where the data is passing through those operations. So in this case, for example, what we're doing is that we're unwinding all the tags, which means we're taking all the tags in all the documents and passing them on. And then we're grouping by the tags and counting. Right? This is the same as group by tags and do a count on each thing as you're used to in SQL. And in result, you basically get this. Databases has a count of 1 and tech has a count of 1. Like, so it's a grouping. This is all in C++. It's really, really fast. And if you download 2.1 already, you can play around with this. So it's really, really useful. Especially if you're not in production. I wouldn't use it in production. You're brave if you do, I think. Alright, GridFS. GridFS is a nice other little thing. Like, so you have the document databases, you have the geospatial indexes. GridFS is like another little candy thing that you can use. It lets you save files in MongoDB, and you can stream those files back to the client. So say you are, I don't know, you have a website where you can upload a PDF or something, and you don't want to deal with like writing a complicated like structure to save it somewhere or something. And we're not talking like streaming video here, right? We're talking like more like ad hoc stuff. You want to save a PDF, but you don't want to set up a completely different file system and everything to do that, or a network attached storage or anything like that. GridFS is like a really nice solution because you can basically just use your already existing code to write data straight to the server, and you can keep it there. So, for example, in Python, you just create an instance of GridFS. You say you open a file, and you do fs.put, and then you will write that file to the grid. In the case of reading it, in the case the simplest thing is just f.get.read. There you go. Node.js driver has a little bit more complex stuff because Node.js has pipes and stuff like that, but every language has at least this functionality here. So the rich documents that we were looking at earlier is like one of those things that is like actually the best part of it, because we always talk about like scalability or all this kind of stuff. But one of the best parts on MongoDB is actually how closely it matches your code. So in traditional relational databases, you always end up having like Hibernate or some sort of other mapping layer between your application and the actual data, right? But when you're using something like MongoDB or any other document database, the difference between the document and the code that's actually using the data is very little. So what we find in general is people throw away tons of code basically when they switch to MongoDB. So less code means less complexity and means less time to put it out there. There's a very rich document expressing an order, like from a typical e-commerce system. So you might have a set of line items, that the person bought. You have a shipping address, a payment, some payment information, and a total. Right? So the idea is basically that this is a single document that you can look at, and it's very, very clear from looking at this piece of information what it is. Right? If you break it up, as you have to do in a relational database, this here would be a separate table with a foreign key. This would be another table. This would be another table. So keeping information together means that the data is very, very easily moved around without having to rely on dependencies to others of the data. So let's talk a little bit about deployment. You can do it as a single server. Just be warned that, like, if it dies, you might lose your data. You need a really strong backup plan. So I would never recommend anybody do this if they're in production. We have a thing called replica sets. Replica sets is basically the concept that you're used to with a master and a slave, but it's richer because it also has failover. So what happens in a replica set is that we have a primary, which is the master that you're writing to, and you have slaves or secondaries, as we call them. If the primary dies for some reason, or you have to take it down because you have to do some maintenance on it, the other two secondaries will basically elect a new primary, and your driver will basically figure that out and keep working. So the idea is that you're able to put replica set into production and take one down at a time, for example, doing a rotational upgrade, for example. You do a rotation like that, doing one server at a time, and you will not be affected by downtime in your application. This is like the minimum set. 2 secondaries, 1 primary, and an arbiter, which is like a server that doesn't do much other than help elections of which server is a new primary. If that has, one of your servers could die and you will still be fine. Sharding is the way of scaling out your application. So imagine that you have to write a lot of data. If you use this system here, you're constrained to like a single primary as your only place you can write. Sharding, basically what it does is like replicate this model across across the whole length. The difference is that when you do sharding, you basically take a key of the data and say, I want to split the data with this key, right? And then what it will do is like write the data to the different servers depending on what that key is, right? And so when you're writing, you're not going to be writing to only one single server. You're going to be writing to a lot of different servers. And those servers that will move the data around to try to keep the data balanced, which means that each server will have hopefully 50% of the data, right? If you have two of them. And that's how you scale up writing. So if you shard, you can take a lot of much more writing because each write will go to different servers, right? And this already exists in other databases, like traditional relational databases and everything, but the main thing that we have is like it's built in already. So you don't have to like get another piece of software or something. It already comes with your MongoDB installation. So use cases, I'm nearly done. I'm on time, huh? Use cases is like whatever, really. I mean, there are a couple of things maybe that's not perfectly aligned with, like maybe writing the actual relationship tree between two people, between people in Facebook. I probably wouldn't use MongoDB. But for the traditional applications, where you would use MySQL or Postgres, you can use MongoDB. There's not really any of those problem domains where it's a bad match. We have tons of people using it. The bigger ones that are more known is like Foursquare. There's like, it's not on here, but there's eBay as well. We have like Inuit Viber, which a lot of people use. Trello. Telefonica as well uses it. And the UK government actually. So I'm just wanting to quickly just say we actually have a meetup. It'll be the second one that we're doing so far. It'll be in Costello Descent next Thursday. Just go to meetup.com and search for MongoDB Spain, and you will find the site and just RSVP, or just if you want to go, just like basically say that you're going to go. I'm going to open a couple of more spots because I had to limit the amount of people that can come because it's the offices of Zing and it's not that big. What else? Yeah, we have like conferences and stuff. There's a MongoDB conference in Paris in the 14th of June, which there are still tickets for if you want to go. I'm hoping to organize one in Barcelona, maybe in September. So stay tuned for that. Depends if I can find space and if we can put everything together. Everything that we have of presentations and everything is available on tangent.com as well. And MongoDB.org is like the main site for that. All right. So, questions? This one. No questions?
Yeah.
Yeah.
When you're in a sharded environment and you have, let's say you have like two nodes and you are doing inserts based on a hash function of the key, who does this hash function and decides which node the document goes? I mean, you need an extra master node, or?
So basically you use a proxy called MongoS. So the only difference from the application point of view is that you point your application to MongoS, and the MongoS is the one that does all the load balancing and also writes the keys to the actual MongoDB databases. But the sharding you basically do in your application by picking the key that you want to do, right?
Yeah, but I mean, you don't need let's say an extra machine to put the master node.
So what the people do, no. Basically you have like the normal thing would do two replica sets, right? One for each shard to make sure that if you lose the master, you don't lose the data. And then you, on each application server, you just have a MongoS proxy, and you point your application to that, and that's it. You need like what is called a configuration server, at least one, that keeps basically where the different pieces of data are, right? Eventually, maybe in the future, those will actually be on the shards themselves, but right now they're on a separate server. Yes?
Yeah, in the use cases, you mentioned e-commerce.
Yes.
which part of the e-commerce? Because I mean, in the transactional stuff, in the classic databases, you always have the transaction thing, and there's no such thing here, or yes?
Well, no, there's no two-phase commit.
Yeah.
But you don't need that. It actually.
But what if it crashes in the middle of the process where you insert many stuff?
Right. So I'm actually next week. I'm talking about that.
Ah, okay.
I'm actually working on an article for InfoQ right now, and I'm going to talk about that on it. Yes, there are some possibilities. You have to handle some stuff manually in rollback.
Sure, but there are some ways to achieve that.
Yes, there are some ways to guarantee, for example, that you don't sell more than you have.
That's stuff. If you want to track stock and that stuff.
Exactly. So there's a couple of ways to guarantee that.
Okay. And another little question, and it's more that I'm curious if you are aware of Mandango, which is a driver for Doctrine 2, which is used in Symfony 2, that actually abstracts the access to MongoDB. If you ever use that, or if you are not aware of something.
But I'm not a PHP guy.
So
but what did you say it was called?
Mandango. It's a Spanish project.
Oh, really?
Yeah, sure.
I'll tell Derek, who's the PHP guy in London, about it.
So if you look at the Doctrine 2 repositories, which is an ORM for PHP to databases, there's a driver for which connect to MongoDB and CouchDB.
Mandango. Okay, I'll have to remember that.
Yeah, the name is a bit funny, but...
Is it somebody from Barcelona? Or?
No, I think it's a guy from Madrid, actually.
Cool.
Or a couple of guys from Madrid. Pablo.
Anything else?
Yeah. I've been using Solar for just puzzle searches in production. I never tried to use MongoDB for just puzzle searches. What is your experience? Would you recommend me to use it in production?
Well, Foursquare is using it in production.
Really?
Yes. Every time you hit something on Foursquare, it's MongoDB. It depends if you need anything more than they are doing. I don't know how rich the Solar Geo functionality is. This has been 3 years since I used it. But you should just look at it and see if it makes sense or not. Obviously, the benefit would be that you could remove one piece of infrastructure. It would simplify your life. I don't know if it answers you, but you should download it and just have a look. In theory, I think it should be good enough if you're not doing very, very complicated GIS kind of stuff. But then you probably wouldn't be using Solar anyway. You'd probably be using PostGIS. So. Yes.
Well, the MapReduce implementation, you say it's just using one thread.
Yes.
Does it have integration with the Hadoop MapReduce?
No. But we have a Hadoop adapter that you can use that is official.
Like an input, to set an input format or something like that?
Oh, well, it basically connects to your MongoDB cluster and lets you stream the data through Hadoop. And it knows about sharding and knows about everything, so it's really good.